Hello, welcome to another video in this series. I know it has been a while, but I want to promise you that I am going to complete this series. I've been busy working on multiple projects. All right, so let's move to the business of the day. Today we want to work on one of the linear data structure, which is the dynamic one, and it is a double linked list. Okay, we've worked on a single linked list in the past. So in this video, we want to work on the double linked list. The first question that will pop up in your mind is, what is double linked list? So a double linked list is a node that has a relationship, and it has a previous relationship and it has a next relationship. So it is linked to another node. So that is a double linked list data structure. You can also make research on your own. So before we start the implementation, let us look at the visualization of double linked list. Okay, I'm currently on Visual Algo and I'm in the double linked list section. Okay, so if you look at this, you can see that this is a double linked list. So we have a node that has the value 38 and which is the head, and it has a relationship with the next node, and the value of the next node is 97. And you can see there is a relationship between the head and the next node, and the next node is also having a relationship to the head. So this type of relationship is established across all nodes. So the starting of the linked list is called the head, and why the end is called the tail. So we are going to implement the whole of this function. So let me insert at the head. So I'm going to insert the value 86 at the head, and you're going to see it in action. So you can see it establish a relationship, and the new node now has the value 86. Okay, so let me insert at, I want to insert at the end, but I'm not seeing it here. Okay, yes, this is the tail. So I want to insert the value 72 at the tail. You can see it establish a relationship, and the new node which has been added to the linked list is now the tail. All right, so I believe this gives you a visualization of how the linked list work. So you can see you can also search for a value. We can search for the value 40 if it does exist. So it's going to traverse, it's going to start from the head and look for this node that has this value. If it does not, then it will just have to return null or undefined. All right, so let us go to the implementation. All right, I'm currently on my VS Code, and you can see I have created a file called double linked list. Okay, so the first thing I want to do is to create a class, and this class is going to have the name as node. Okay, there's going to be a constructor. Let me see, there should be a shortcut. Okay, yes. So in the constructor, we want to have after the self, we want to have another value, and this is going to be the data we want to pass into the double linked list. So we're going to have the self dot data is going to be the data. So this is the value, right? You can see in this node here, each node has a value. Okay, so this is going to be the value. So this variable is going to hold every value of the node. So note, we need to establish a relationship. So this relationship is going to be a forward and backward relationship. So in that case, we are going to have next. Okay, and by default, this next will be none, and we're also going to have the previous. By default, this previous will be none. So the next thing we want to do is to create the double linked list class. So I'm going to create another class. I'm going to call this double linked list. I hope I spell it correctly. Yes. Okay, so this is also going to have a constructor, and in this constructor we only want to have the self, okay, which is the default one. So our double linked list is going to have a head and a tail, which is the starting and ending, just as you've seen here. It's going to have a head and a tail. So by default, the head should be none. Okay, and same thing applies to the tail. The tail should be none. Okay, so we have established the link list class, which is this one, and we've also established the node class. Okay, so if I go to my slide, okay, yes, if I go to my slide, you can see I've talked about this before. We have the head, we have the tail, so there is a relationship, and each node that exists has a previous and next property with each value. Okay, so the first one we want to implement, the first method we want to implement is to check if the linked list is empty or not. Okay, 1 minute. Okay, so we are going to create a method is empty, and what this method does is it's going to check if the head of the linked list is empty. If it is empty, we have to return true. If it is not, we return false. Okay, this is going to help us to implement other linked list method. Okay, so let us implement that. I want to define the name of the function, which is empty. Okay, so this is going to be all we just need to do is to return the head, which is self.head is none. So this part of the code, it is the same thing I'm checking if the it's the same thing I was doing like this. If self.head is none, return false. So this is the same thing as doing like this. So what is going on here is we are returning the head if it is none or not. So this is going to return a boolean value. Guys, now we want to implement insert at the tail. So let me zoom in. I believe this is next. Yes, this is it. Okay, so the first thing we need to do is to create a method insert at tail that takes a parameter. Okay, so let us do that quickly. Insert at tail. Okay, so this is going to take a parameter. Remember, we need to put the self because it is the property of a class, and we need to put the data. Okay, so the next thing we should do is to create an instance of a new node. Okay, using the new value. Okay, to do that, all we need to do is to create a new node, a variable which is going to be a node of the new value. Okay, going back to this, you can see the next thing we need to do is to check if the linked list is empty. If yes, set the head to the new. Okay, so to do that, so we need to do if self dot is empty. I think there should be, yes, if self dot is empty, meaning if it is empty, so We want to do self dot head is equals to the new node. Okay, and we also want to assign it to the tail. So self dot head, or tail rather, tail is equals to the new node. So this is going to be the first item in the link list. Okay, so it says otherwise find the last node and set the next property of the last node to the new node. Okay, it also says set the previous property of the new node to the last node. But let us do this one first. Let us do this one. So it means if the linked list is not empty, so this is going to be S. We want to change the position of the new node. Okay, so we want to swap the new node. So we want to perform this action. Let me show you again. Let me show you. Insert the tail. So the tail will now become the previous, and the new tail will now become the new node we just added. Okay, so that is what we want to do here. So this is going to be the new node dot previous. Why am I not saying previous? Oh, sorry, I made a mistake here. This should be node. Okay, so this is going to be previous. So the new node, which is the previous, is going to be the self.tail. Okay, self.tail. And now the next property is going to be the new node. So this is going to be self.tail next rather next with the next property. So is going to be the new node. Okay, and one more thing, we also need to point the node to point the current tail to the new node. So this is going to be self dot tail, right, is going to be the new node. Okay, I hope you understand what is happening here. So this is the new node, right? The previous property is pointing to the tail. Okay, and the next property of the tail is pointing to the new node. So we also need to establish the relationship, which is the current tail. So this part is setting the current tail. Setting okay, sorry, let me do set the current tail. Okay, so this part is establishing a relationship. I hope you understand. This is just establishing a relationship between the new node and the previous node. So this part, all we're doing here is to set the current tail as the new node. Okay, we're going to test all of this. So guys, I think the best thing to do now is to implement the display method so that we will see what we have in our double linked list. Okay, so let's go to my pseudocode. Um, let me go do the, okay, display. Okay, so this one is display forward. Okay, so we want to implement this. All right, so the first thing we need to do is to create a method display, but I'm going to call it display forward. Okay, so I'm going to name that function display forward. Okay, with the self, this doesn't need an extra parameter. So what I'm going to do here is I am going to get the current item. I want to loop across all the value in the linked list and print them out. Okay, so it's a check if the linked list is empty. If it's empty, return false. So let's do that. So if self dot is empty, it should be empty. Okay, we should return false. Okay, say otherwise loop through the linked list and print the value in every node. Okay, so I want to get a current node. So to get that, this is going to be self.head. I want to loop from the head. Okay, head. All right, so why there is an item, why the current is not none. Okay, I want to print the value. So I'm going to print current dot data. I think there's data, yes. Okay, then I need to add a space, and in Python you can do that like this. Okay, let me even add something like a link. So I'm going to add something like a link like this. Okay, this is going to give me that link in between. So in order not to end up in an infinite loop, we need to continue setting the current. So the current is going to be current.next. Okay, so with this we can see what is going on in our linked list. So let us add some elements to the linked list. So I'm going to create an instance of the linked list. So I'm going to create something like this, linked list. No, this should be double linked list. Double linked list, which is going to be an instance of the class. Okay, so we can now do double linked list dot, I think we have one method, insert at the tail. So I want to insert one, and I want to insert two, and also want to insert three. Okay, and okay, one more, I want to insert four in my linked list. So thereafter, I want to print out what we have in the double linked list. So I think we have display forward. Okay, so I hope everything is going to work. I can click on run, but I'm not sure my system is misbehaving these days. Okay, we can just run this file. So okay, let me try this one first. Run. Okay, good, it works. So you can see we have 1, 2, 3, 4 items in the linked list. If I change the order and 4 as the second value in the linked list, and I'm going to print it out, you can see that here we have 1, 4, 2, and 3 in the linked list. So next we need to implement insert at head. All right, let us do that quickly. Let's create a method insert at head that takes a parameter. Okay, so insert at head. So this is the method of a class. So you need to put the self, and you need to put the data you want to insert. Okay, so it says create an instance of a new node using the new value. Okay, so I'm going to call this new node and the instance. So next I'm going to pass in the value, which is the data. All right, so if you look at our list, it says check if the linked list is empty. If yes, set the head to the new node. So we're going to check if the linked list is empty. Thus is empty. Okay, so if the linked list is empty, we want to set the head and the tail as the new node. So we're going to do self.head is equals to the new node, and self.tail is equals to the new node. Okay, let us look at our pseudocode. So you see, otherwise set the next property of the new node to the head. Okay, set the next property of the new node to the head. Okay, so what we're going to do is else the next property of the new node should be set to the head. So next is going to be self.head. Okay, and it says set the previous property of the head to the new node. Okay, So to do this, so we are going to do self.head.previous is going to be the new node. Okay, so this is taking the position of the head. Okay, finally set the head to the new node. Okay, so finally we're going to set the head to the new node. Okay, this is going to be new node. All right, so basically if we go to our visualization, you can see, okay, this is what we want to do. So if I insert at the head, okay, so this relationship is what we just established here. This part of the code, right, is this relationship. Okay, so we've written that, and let us test this. This is insert at the head. So we need to call our link list before the printout, our double link list. So insert at the head. Okay, now let me add 44. I'm going to save this and run, and let us see what we get. Now you can see we have 44, which is now the value in the head. Okay, let me add one more value. And this time it's going to be 48. Save and run. So we have 48 as the head, and the previous node that has the value 44 is now the next node of the head, which shows it's working perfectly. Guys, the next method we want to implement is insert at a position. So let us read the pseudocode. It says create a method insert at position that takes two parameters, the position and the value. Okay, let us create that quickly. So insert at position. Okay, this is going to take self as a method of a class, and if you take the position and the value, okay, position and the value, or can call it data. Okay, anyone work. Now the next thing says if the position is less or equal to 0, insert it at the head. I think we should not allow anything less than 0 because there's no position that is less than 0. I think this documentation needs correction. So let us add a validation here. So if the position is less than 0, we want to just stop the execution. So what I'm going to do is if the position is less than 0, I want to just print to the console position must not be less than 0. Okay, all right, let me stop this. Okay, so after this we want to return. I think let me increase my screen so that we can see. Okay, we just want to return, so we have to stop the execution, telling the user that the position must not be less than 0. So back to the pseudocode. So it says now we cannot do if the position is 0, we are going to insert at the head. Okay, but we should create an instance of a node first. All right, so let us create the instance of the node. So I'm going to call this new node. The new node is going to be node, and we need to pass in the value we want to pass in, which is the data. So if the position is 0, if the position is equal to 0, we want to insert it at the head. Okay, so this is going to be new node dot next is equal to self.head. Um, I think instead of calling this again, we already have that method. So all we need to do is we need to call that method insert at head. Okay, and we pass in the data. Okay, we are not passing in the node, we are passing in the data. So this is going to insert at the head. So we already have this method, no need of writing it again. Okay, so it says next, find a node in the given position and set the next property of the node. So we need to find that node with the given position and setting the property. So finding that node, we need to loop. Okay, if you look at our example here, let me say for example, I want to insert at a particular position. Let me select 3 for example. Okay, let me select position 3 and go. Okay, you can see that it locates that position is very fast, though it locates that position and the connection, the relationship has been established. Okay, so next, this is what we want to do. We want to loop through, we want to look for that node with a given position and establish the relationship. Okay, so this is going to be my else I want to get the current node, and the current node is going to be self.head. Okay, so I want to also loop, so I'm going to use a for loop, a for loop using a range. So for I in range of position, now if I leave the position like this, I'm going to run out of bound, so it should be -1. Okay, then I want to traverse the current node. So first of all, I also want to check if the current is none. Yes, if the current is none, I just want to print to the user that the position is not found. Is not found. Okay, and I want to return. Okay, otherwise I want to set the current. I want to set the current to the current.next. Okay, so by doing this, we won't fall into the infinite loop. So the if the position is found, this is where we'll now establish that relationship. So this is going to be new node, a new node.next. This should be next. New node.next is going to be the current.next. Okay. Also, the current.next is going to be the new node. Okay, so current.next is going to be the new node. All right, I think this is all. Let us test this out. Insert at a position. So we're going to call this after. So we're going to call double linked list. Double linked dot insert at a position. So this need a position. First of all, let us try a negative position. So I'm going to try -3, and I want to insert 6. Okay, so I'm going to see if the expected behavior should be, it should tell us that the position must not be less than 0. So let me run this code. Let us see the result. Let me expand my terminal. So I'm going to run. So it says position must not be less than 0. We can see the value 6 did not go into the double linked list. Okay, so let me add position 1. In fact, position 0 first. Let us test this behavior. So I'm going to run again. Yes, excellent. We can see we have the value 6 at position 0. Okay, so let me change this to position 1. I'm going to save and run. Excellent. We have the value 6 at position 1. What if I change it to position 3 and save? So I have 6 at that position, which is 0, 1, 2, 3. All right, so what if I specify a position that does not exist? I'm going to specify 66, for example, and I'm going to run this code. So it says position is not found, and you can see the value 6 did not go into the double linked list. All right, guys, so that is the implementation of insert at a position. So next we want to implement search. So guys, we want to implement search in a linked list, and before we implement the search, let us see how it works. So I want to search for the value 76 in a linked list. So I'm going to press go, and if you look at my right hand side, you can see there is a loop going on because we're searching for the item. So if the item is not found, it's going to return not found. So let me search for an item that does exist in the double linked list. So I'm going to search for the value 3 in the double linked list. Okay, so we are looping, searching for that value, and we get to that value and we return the index. So what we want to return is the index. It actually depends. You can return the index or you can return the value, but it actually makes sense you return the index. First thing we need to do is to create a method search that takes a parameter, which is the value, and this is going to be an index, and check if the double linked list is empty. Okay, let us do that quickly. So I'm going to implement that here, and this is going to be search. Okay, so this is going to be the index. Okay, so I'm going to put the index, and it says we need to check if the linked list is empty. So check if the linked list is empty. If it is empty, we'll return false. To check if the linked list is empty, so I'm going to do if self dot is empty. Dot is empty. Okay, we should just return false. Okay, you can return none depending on you can just return anything you want, but it should be false or none. Okay, go back to our pseudocode. It says otherwise find the node that its value correspond to the given parameter. If found, return the position of the node. If not found, return false. All right, so to do this, we need to look through the linked list. As you can see in this example, you can see they're using a while loop to search for the particular node. So I'm going to do while. No, I should set the current first. So I'm going to set the current, and the current is going to be from the head. Okay, then my while loop coming. So while current, okay, why the current is not none. Okay, I want to keep on searching for a particular index. So I'm going to do if current dot, if I do current dot data, right, equals to index, and I'm going to get the right result because we are looking for index and not the data. This will not work. So what I have to do is to set a count. So I'm going to set a count which is equals to 0 by default, and here, so what I'll check is if count is equal to position, is equal to index rather. If count is equal to index, so I want to return the count. Okay, I want to return the count. Okay, otherwise I don't want to end up in an infinite loop, so I am going to do current is equal to current.next. Okay, then I also want to increment the count. Count plus equals to 1. All right. So if at the end of everything we loop through and would not see any matching index, so we want to return none. Okay, let us test this out. Okay, let us test this out. So I am going to call double linked list dot search. I want to search for a particular index if it does exist. So I want to search for index 1 first. So I'm going to save and run this code. I believe everything should work. I'm going to clear my console and run. So it says position not found. Okay, I think this is coming from something else. Okay, let me comment out this one. Okay, let me comment out this one and I'm gonna run. So I'm gonna run again. Okay, absolutely we are not getting any results. So okay, it looked like this method is not working and I need to look at it closely again. Probably I made a little mistake. So guys, the reason it's not working is because I was actually comparing the value and the index. I was comparing the counts and the index. I should compare the node value and the index. So this should not be an index. This should be value. So I'm going to change this to value because you want to check if a particular value is in the linked list. So let me give an example again. If you look at this, we want to search for the value 3 in the linked list or 83. Okay, so it's going to search for that item and it's going to return the index. Okay, so this is going to be the value, and so here what should be is if current dot data is equals to value. Okay, we want to return the count. Otherwise, it should just continue like this. Okay. Alright, guys. So I'm gonna save and roll down. So I think I should even move this to the top first, so that I will see the behavior. So I want to search in an empty linked list. So I'm gonna run my code. Okay. It doesn't return anything. Search is not producing result. Okay. We need to debug. So I'm gonna add my debug statement here, my breakpoint. I'm going to add my breakpoint here. Then I'm going to debug. I'm going to run. So we want to see what is going on in the search and why it is not returning the index. So I'm going to step into. So if it is empty, obviously we know it's not empty. Okay, you're going to step out of this one. Then, okay, it's not empty. So we start from the current item. And I want to watch current.data. Current.data. Okay, which is 48. Current data is 48, but we're looking for 44. So next, I'm going to current. And okay, current data is now 44, and this is what we are looking for. You can see our count is 0, so count should be 1 by now. Okay, so obviously this is what we want. Yes, the current data is now equal to 44. So it should return the count, which is count is 1. It's returning the count. Okay, I think I seen where the problem is coming from. So we need to set the index here, right? We need to set the index here and print it out. So it's a return statement. We need to capture the index. Sorry about that. So I am going to set it index. And this is index. Okay, so I'm going to stop this from debug mode and go back to normal mode. Okay, let me remove this. Now let me run. Good. So you can see we have 44 at index 1. So what if we decide to search for the value 2? I'm going to save and run. We have 2 at index 4. So basically this means the search functionality is working properly. Alright guys, so next we want to implement display. We've implemented display forward. I think it's display forward. Let me check. Yeah, display forward. Okay, so we want to implement display backward. So to implement display backward, it's very easy. You can pause the video and work on it yourself. Thereafter, you can come back and see my solution. So I'm going to give the solution straight away. I'm going to just duplicate this line. Then I'm going to rename this as display backward. Display backward. Okay, so if you notice here, we are looping, we are taking the current from the head. So to display backward, we need to take it from the tail. From the tail. Okay. When it has been taken from the tail, so instead of taking it from next, we should take it from the previous. That is all we need to do to implement display backward. I'm going to see it in action. We're going to see in action. So this is going to be, I'm going to duplicate this line and call it display backward. Okay, so I'm going to run. I'm going to run my code. Okay, there should be like a breakpoint. Okay, let me add like a new line. What I'll do here is just add another print statement and I'll call this end and print. Okay, I'm going to do the same thing. I think this one is okay, so let me just save it and run again. I'm going to run this. Okay, you can see the one with end print. You can see this one is the display forward. So you can see this one is starting from the back, which is 48, and display backward. So guys, we have more two methods to go, which is remove from the head and remove from the tail. If you have watched video to this extent, please ensure you like this video and subscribe if you have not, and make sure you drop your comment, drop your opinion below. So remove from the head. Okay, so if you look at the double linked list visualization, I'm not sure. Okay, there is. Okay, so I'm going to remove from head. All we need to do is to go to the head and remove the head. You can see the head is gone, and we can also remove from the tail. We can remove from the tail, and look at it, the tail is gone. So this is what we want to implement, but first let us remove from the head. Okay, so remove from the head, we need to create a method remove from head and check if the double linked list is empty. If empty, we want to return false. Okay, let us implement that. Okay, let me minimize all these methods we already have. These are working and they are confirmed. I'm going to minimize this. Okay, so this is going to be remove from head. Okay, self and the method of a class. So it doesn't need to take in any other parameter. So the first thing we need to check if the method, if the linked list is empty. So if self dot is empty, we just want to return false because we don't want to remove, we don't have anything to remove from an empty linked list. We have only one item in the double linked list. We should remove it. So to check that, we need to do if self.head is equal to self.tail. Same thing we did for the remove from head. So if this is true, we want to do self.head is equals to none, and self.tail, okay, self.tail is equal to none. All right. Otherwise, no, we should return true here. We should return true. It depends. Some people do return the value that is being removed from the linked list. I'm going to show you how you can do that. Well, let us finish this implementation first. So otherwise, let me put my else statement. So otherwise, we also want to establish the relationship. We want to filter out the last current tail. Okay, so to do that, we need to do self.tail will be equal to the self.tail.previous. Okay, so self.tail.previous. Okay, then the self.tail.next is going to be null. Okay, self.tail.next, this is going to be none. Okay, we also want to return true. All right, so let us test this out. Remove from tail. I'm going to copy the name, and where we tested remove.add, I want to put remove.tail. So I've saved my code. I'm going to clear my console and I'm going to run. However, if you don't have this play button, you can run your code using Python 3. Then the name of the file. The name of the file is double linked list. It's still the same thing. Okay, if you look at this, we have 3 as the tail. Now we have 2 as the tail. This shows the double linked list is working. The method remove from add is working. So what if you want to return the name or the value of the data? If you want to return the value of the data, all you need to do is to get the data before the before you are setting up the relationship. So the data is going to be self.head.data. Okay, so when you get this, anywhere there's true, you just have to return this data. Okay, there's true here, you return this data. Same thing for the tail, self.tail. Okay, no, this should be data is equals to self.tail.data. Okay, so you need to put data here and you need to put data here. Okay, and we can get that value where is removed from tail. So we can get that value here. I'm going to call this data, and at the break I also, okay, let me just do like this, then data. Okay, so I'm going to save and run this again. Okay, so we have 3, which is the previous tail has been removed, and you can see the value here. So this shows how the double link list work. Okay, there is another method which I'm not going to implement. It's going to be pretty easy, but I believe you can do that on your own. So this method is remove at a particular index. So I believe you can do that now, watching all the steps we've taken so far. So the next thing we want to work on is the time and space complexity for each method. So guys, the space complexity, let us start from is empty. The time complexity of this is O of 1 and O of 1 time, and the space complexity is O of 1. O of 1 space. So there is no extra space and there is no extra time. So this is constant time. You can see that we're accessing this item here. Okay, let us check this one. So insert at tail. Okay, is there a loop? So to check for the time complete, you need to check is there a loop. If you look at, there is no loop. Okay, insert at the tail, there is no loop and there is no extra space. So this is the time complexity. This should be O of 1, which is constant time, and this is also constant space. This is constant space. So next we are going to look at this method insert at the head. So for the time complexity, the first thing we need to look at is there a loop. So insert at the head, if you look at it, there is no loop. Since there is no loop, the time complexity here is O of 1. Okay, and the space complexity, okay, and the space complexity here is O of 1. There is no extra space that has been created. All right guys, so if we check display, so the display, what we are seeing here, the display is O of n time, because there is a loop. We are looping through an item. However, we are not allocating an extra space. So this is O of n time, O of n time, and O of sorry, this is O of 1. This is going to be constant space. Okay, so if you look at the method display backward, this is the same thing as display forward. There is a loop and there is no extra space here. Okay, if you look at insert at a particular position, okay, we have a node here and we are doing a loop. So this is O of n time, this is O of n time, and this is O of 1 space, which is constant space. Okay, the search, this is O of n, this is O of n, because we are using while loop to search for a particular index. So this is O of n time, and there is no extra space, so this is O of 1, which is a constant space. All right, remove from the head. So if I remove from the head, first of all, you can see there is no loop and there is no extra space. So this is a constant time and a constant space. Okay, remove from tail. Okay, there is no extra space because the tail is closer. All we need to do is to get the last one and shuffle it out. This is the same O of 1 time and O of 1 space. So guys, that is all for double linked list. Thank you very much for joining me in this video. Watch out for next video, is going to be much more interesting. So I don't want you to miss out. In the next video we want to look at, probably we're going to look at stack, but just keep on the watch. Ensure you like, ensure you drop your opinion using the comment section. If you feel there is any correction I need, please drop it to the comment section. Thank you very much for watching guys. I'm going to see you in another video.